Alright, let's do some complex sine and cosine graphing here. This is the complex sine and cosine graphing problems number 1 assignment. We're going to take a look at numbers 3 through 6. And what I've done is taken the solutions that you can find online and thrown some extra notes on here to really solidify where these values are coming from and hopefully help you get a better grip on how to accurately graph complex sine and cosine graphing problems. So the directions for each of these are to graph one full period for each of the following trigonometric equations and label your axes with the correct values and make sure to include the origin. In class I had initially said that the origin had to be the point 0, 0, but as long as you have one full period of your graph, I'm not concerned about you having the origin be an actual point in your graph. However, you do have to accurately label your axes, and that's probably the most challenging part of these problems. So taking a look at number 3 here. Number 3, as soon as you see it, you should recognize that it is a cosine graph. So that is the first and foremost thing to identify. And after you identify that it's cosine graph, you want to label A, B, C, and D. So in this case, A is 2, the number in front of the cosine graph. It is positive, which means that there's no reflection. So when we graph our cosine graph, we're going to start at a peak. If this was a negative A value, then of course we would start at a valley. The B value is conveniently factored out for us already, so B is 2. The C value is in front in this case, it's negative 2, and the D value is a positive pi. However, what we have to remember with the D values, we're going to think opposite. So based on those values, we get the amplitude from A. So the amplitude is positive 2. That'll be the distance from the midline to any peak or valley. The period is calculated by taking the standard period of cosine, which is 2 pi, and dividing it by our B value, which is 2. 2 pi divided by 2 is pi. And then we make a note to ourselves that this is a full period, a full new period for this graph. And in order to graph it, we're going to have to break that full period into fourths. So I make a note over here that pi over 4 is going to be the amount I have to move to get to my next important point on the graph. You'll see how that plays in once we get to actually graphing this in a second here. The vertical shift comes from the C value. Since C value is negative 2, that means we're going to go down 2. And the phase shift is listed as negative pi, which really means that we're going left pi, because you can see up there the plus pi, think opposite, go left pi. So the graph is already done here for you. And I really highlighted the midline and the upper and lower amplitudes with the red marker here so that you can see them. And where those came from, the first thing that you graph is the midline. So since the vertical shift is down 2, you get your dashed line going through y equals negative 2. And then from there, you make your upper and lower amplitudes. Since the amplitude is 2, you go up 2, make another dashed line, go down 2, make another dashed line. So you get those 3 lines that show you your upper, lower, and of course midline for any of your sine or cosine graphs. Once you have that, your next thing is to determine where is my starting point going to be. So this is a cosine graph. Cosine graphs always start at a peak. Normally they start at a peak on the y-axis, but because we have a shift to the left pi, you can see that my starting point is here at the upper part of my graph, so I peak, and it is at negative pi because I went left pi. I know I need 4 more points in order to graph this function correctly. My next one's going to have to go down to the midline, and then down to the valley, back to the midline, and back up to a peak to complete a full period of this graph. So where did I get the negative 3 pi over 4, negative pi over 2, and negative pi over 4 from? That came from this note right here. So we know that a full period of this graph is pi. In order to get to my next important x value, I have to add pi over 4 to the previous x value. So if you take negative pi, which we can do off to the side here, if we take negative pi and we add pi over 4 to it, going to have a little bit of fraction work, so we'd have to put the negative pi over 1, multiply top and bottom of this fraction by 4 to get a common denominator, so that we have negative 4 pi over 4 plus pi over 4. And when you add those together, you have a common denominator, and negative 4 pi plus 1 pi gives you negative 3 pi over 4. That is where that x value right here comes from. Where does negative pi over 2 come from? Well, I take negative 3 pi over 4, and I add pi over 4 to that to get to my next important x value. Already have that common denominator, which is convenient. So negative 3 pi plus 1 pi is negative 2 pi over 4, which reduces to negative pi over 2. To get my next one, I would take negative pi over 2, and I would add pi over 4 to it. Ironically, I'm going to go back to negative 2 pi over 4 because I have to get that common denominator again. So when I multiply top and bottom of this fraction by 2, I get negative 2 pi over 4, which gets me that common denominator. And negative 2 pi plus 1 pi is negative pi, and that's where the negative pi over 4 important x value comes from. To get my final important x value, I take negative pi over 4, and I add pi over 4 to it. This is about as good as it gets because we have the common denominator, and negative pi plus pi is 0, and 0 over 4 is 0, which is why we end up right here at x equals 0 for our final important value of this graph. So once you decide what your amplitude, period, vertical shift, and phase shift are, it's just a matter of getting the amplitude from the midline. So you start with the midline, then you get your upper amplitude and lower amplitude. Decide what your starting point is. So am I starting at a peak, which you do for all positive cosine graphs? Am I starting at a valley, which you would do for all negative cosine graphs? Or am I starting on the midline, which you're going to do for any sine graph? It's just a matter of, am I going to start going up to the right, or am I going to start going down to the right, which is based on whether it's a positive sine or negative sine graph. Then you got to do a little bit of work to get your x values, and some of you, and you know your strengths, some of you are good with fraction work and you're not going to have to write out all the work all the time. Some of you know that it's one of your weaknesses, so you may have to write out the work like I did off on the right there with the red pen here. So the next three problems, we can kind of cruise through a little quicker here. So in number 4, when you look at the equation, it kind of looks weird because it's almost as if there are numbers missing. So you can see here what I did was I labeled some things that were not labeled. So the number in front of sine, obviously that is your a value. There was nothing in between sine and that parentheses next to the x, so what's there is a 1, which is why your b value is 1. D is clearly negative 3 pi over, or is 3 pi over 4, I should say. But there was no C value, so if there's nothing added on the end or in front, then that means that C is 0, which is pretty convenient because that means that there's no vertical shift. So the rest of these values came from the explanation above. Amplitude is 5. Since it's positive, there's no reflection over the midline. The period is always calculated for sine and cosine by taking the standard period of 2 pi divided by your b value, which is why we get a period of 2 pi. I made that note to myself. If I take 2 pi and divide it by 4, that means that when I simplify it to pi over 2, that's how far I need to go to get to every next x value that's important. No vertical shift, like I said, because C is 0, and the phase shift, we're going right 3 pi over 4 because we have to think opposite. That minus sign, think opposite, go right 3 pi over 4. So I got my midline on there, which was right on the x-axis because there was no vertical shift. I went up 5 and down 5 to get my upper and lower amplitudes, and then I had to pick my starting point. Now this is a sine graph. All sine graphs will start on the midline. It's just a matter of, do I go up from there or do I go down from there? So I started at 3 pi over 4 because of my shift to the right 3 pi over 4. And I knew I was going to have to go up from there because it's a positive sine graph. So I knew I was going to go up to the peak, back to the midline, down to the valley, and then back to the midline. So how did I get these x values? Well, from 3 pi over 4, I knew that I had to go pi over 2 to the right to get to my next value. Well, in order to do that, I would add 3 pi over 4 plus pi over 2. I'm not going to show the work for it this time, but that ends up being 5 pi over 4. So why did I go 2 units then? Well, in order to keep my intervals accurate, you'll notice that to get to 3 pi over 4, I went 1 pi over 4, 2 pi over 4, 3 pi over 4, which means I can't just go one more marking to the right because that would be 4 pi over 4 or just pi, which means I had to go by pi over 4 on my x-axis in order to create an interval that worked. And sometimes you can't just go by ones, intervals of 1 on here. You're going to have to go by whatever interval works out. The general rule of thumb for this is you need to find out what's your common denominator between your new period over 4, so in this case pi over 2, and 3 pi over 4. So what's the common denominator between pi over 2 and 3 pi over 4? It's 4, which is why you have to go by pi over 4 in order to get the correct intervals on here. We'll talk more about that as we practice these, but that is why the intervals were 2 apart instead of 1 apart, because in order to get pi over 2, you actually need 2 pi over 4s. Number 5 real quick. C is the number out front, which is positive 3. A is positive 1/3, so again it's positive, no reflection over the midline. Cosine of 3x looked kind of weird, but really that 3, if you factor it out, is your b value, and then there is nothing inside next to the x, which is why d is 0, so there is no phase shift. Based on that, I got my amplitude of 1/3. My period I found by taking 2 pi divided by b, which was 3. So 2 pi over 3 is my period. I then took 2 pi over 3 and divided it by 4, which meant I had to multiply by the reciprocal of 4, 1/4. That gave me 2 pi over 12, which reduced to pi over 6, and that became the value that I needed to use to get to my next important x value on the graph. The vertical shift was from our c value of positive 3, so you can see that my midline was shifted up 3. You can see that I went up 1/3 and down 1/3 to get my upper and lower amplitude, so I had to use sort of a different scale here. I went by thirds on the y-axis. And then for my x values, there was no phase shift, so this is a positive cosine graph. I just started up here at a peak. And then to get to my next spot, I knew I had to go down to the midline, which had to be pi over 6 away. And then I went every pi over 6. The only reason that the answer key goes by 2 units for every pi over 6 in this case was because otherwise it would be too crunched together. The last graph here, number 6, this one was not set to go for you. So you knew your c value was -1, you knew your a value was -2, but here's one where that b value is not factored out. So you had to factor the 2 out and then rewrite this as x plus 2 pi. You should really double check your work and distribute that back, make sure you get back to what you started with. But as long as you factor that b value out correctly, you get a b value of 2 and a d value of 2 pi. This one also is a little different because our a value is negative. So we have an a value that's -2, which means our amplitude is still 2. Amplitude's always positive, but we have a reflection over the midline. So this sine graph is going to start at the midline, but because it's reflected, instead of going up as we move to the right, we start out going down as we move to the right. The period comes from taking 2 pi divided by the b value of 2, simplify that to pi, and then make a note to yourself that pi over 4 is how far we need to go to get every next important x value. Vertical shift of -1 comes right from the c value, so we're going down 1. And the phase shift, or horizontal shift, excuse me, in this case is left 2 pi after we rewrite that and factor the b value out. When you put it all together, you got your midline at y equals -1. You go up 2 and down 2. Again, the only reason that the answer key goes by halves on the y-axis is so that it's not all crunched together. And then your starting point for this was right here at -2 pi on the midline. And then I knew I had to go pi over 4 in the x direction to get to my next important x value. Y go by, y spread it out, same thing, so that it's not all crunched together. So at the end of the day, your job is to graph any complex sine and cosine functions. You do so by using the same process. And it does take a little bit of practice, especially with getting your important x values, but once you get the swing of it, they're all kind of the same.